Well, hello, Caymans. This is Mr. Eicher coming at you with a Chapter 4, Section 9 lesson on modeling with polynomials. Doing some word problems today. We have 2 pages in our notes. If you've printed this, kudos to you. So let's jump right in. The gas prices in dollars at a gas station in a certain town follow the polynomial graph shown to the right. The x-axis represents time in months. T equals 0 will be May, just to make sure you can see where the axes are. Here's the y-axis. Here is the x-axis. And we're told the x-axis is time in months. So our T for time equals 0 is May. And it looks like it goes all the way up to 12 out here. So T equals 12 would be what's that, April? Actually, it would be May, since we started at t equals 0 is May, not t equals 1 is May. So I counted on my fingers and found that May is the 12th, t equals 12. And we're told the y-axis represents the increase, and that's underlined, so it must be important if it's underlined like that. The increase in gas price, so here's gas price, is this axis. And it's the increase in gas price in dollars, or units here, dollars, after t equals 0. So on this page, we'll have several questions about this one single graph. Our goal is that you'd be able to understand what the different points mean in a context. Obviously, a lot of times in math class, we solve equations and we have all these numbers thrown around, but we think it's really valuable for you to be able to interpret things with actual data and real-world context. So part A says there's a relative maximum at 2.785, 0.964, so this point right here. So that's called a relative maximum. We call it relative because points over here might go higher, like they look like they are higher. But we call it a relative because relative to points around it, all this neighborhood around it, it's the highest point in the neighborhood. So that's a relative maximum. Maybe there's a point out here that's higher, like this point right here. We might call that an absolute because on the graph it's the highest on the graph, an absolute maximum. But we're asked in part A, what do these coordinates tell us in this context? So remember, the x-coordinate here is the month after May. So if t equals 0 equals May, then this would be 2.785 months after May, something happens after May. So what would that be? T equals 1 is June, t equals 2 would be July, so sometime in late July. So late July would be 2.785 months after that. And then what happens? We have this value, and that's the increase in a gas price at a certain gas station in a certain town. And we don't know how much the gas actually costs. The gas does not cost 96 cents a gallon, but that's the increase. So we would say that many months after May and late July, the gas price was $0.964, so about $1, more, because it's an increase, than it was in May at t equals 0. So again, we don't know. The gas price could be $5 a gallon, it could be $2 a gallon, but from this graph, we can tell that in late July, the gas price had increased 96 cents compared to where it was originally. And you can see I asked a similar question for B, but B is going to be on your try this. So you could answer it now if you want to save yourself time later. But we're asking about the relative minimum on the graph for that try this. Let's move on to part C. What do the zeros, and I'll highlight them for you, what do the zeros at t equals 7, that point right there, and t equals 11 represent in this context? Well, remember that the y-axis is the increase in gas price. So if that increase is at 0, then that would tell us that in this month, t equals 7, so in t equals 7, which let's see would be, if May is 0, we would have June is 1, July, August, September, October, November, December. So that's 1, 2, 3, 4, 5, 6, 7. So in December, the gas price was equal to the price in May. Same thing for t equals 11. T equals 11 would be, I think, April. Also, same thing. In t equals 11, that would be April, the gas price was the same as in May, the t equals 0. So all of these values, t equals 0, t equals 7, t equals 11, they have the same exact gas price. Question D says, the initial cost of gas in May was $3.19. So we finally find out what was the actual gas price, not just the increase and decrease, but what was the initial cost of gas. It was $3.19. What was the highest price of gas at this gas station based on this graph, and when did it occur? So if you originally cost $3.19, then based on this graph, the highest price of gas would be at this maximum value, this relative maximum. And specifically, it would be this much of increase from $3.19. So originally it was $3.19. The increase was 96 cents. And then we would add those, and that would be our highest price that gas was at this gas station during this calendar year. So we'd get a price of $4.15. So that would be down here, we had $3.19 plus the increase at the highest point, and that gives us $4.15 with a 4 at the end there. So the highest price was $4.15. When did this occur? This occurred in late July. And that would be the x-intercept at the time. The x-intercept would be 2.785. 2.785. There we go. So that was D. And then the question E will be for you, as a try this. Question F will be our last one in this video, and then you have G as a try this. Find the average rate of change from May, that equals 0, to the maximum. So we'd like to know, when we say the average rate of change, we'd like to know how much the increase and decrease of gas price changed over the month. So it didn't always stay a constant value. But when we're asked for average rate of change, I abbreviate that as AROC, average rate of change. When you're asked for average rate of change, I believe we've seen these before, but we're basically being asked to calculate the slope of the line that passes through those 2 points. So the slope of the line that passes through those 2 points visually, we would have this point is the t equals 0 point, and this point is the maximum that we were asked about. And we'd like the line that passes through those 2 points. So we'd like to know the slope of that line, and that would be the average rate of change. So the slope of that line, we would have the formula for slope would be, in general terms, the difference in the y's over the difference in the x's. You could also write that as the change in the y's over the change in the x's. We use triangles to represent change, or delta is the Greek letter. That triangle is a Greek letter, not just a triangle. In our units, we would have dollars for on the y-axis, and we have months in the x-axis. So we would have the value, that 96.4 value, minus 0, there was no initial change when t equals 0. And for months, it occurred at 2.785 minus 0. Again, these are zeros because in t equals 0, the dollar amount was 0. There was no increase That was just our starting point. That doesn't mean that the gas was free. That means it's just our starting point, and from there we check the increase and the decrease. So calculating this, we would have 0.964 divided by 2.785. This gives us an answer of 346. And what are the units of that? Well, we said the units were dollars per month. And I hope that makes sense as a rate of change. Rate of change. How much did the gas increase or decrease change over time? And this would be this many dollars per 1 month. So it looks like, based on this data, that the price of gas increased. The price increased about 35 cents. Roughly 35 cents per month. And that's how we'd interpret that slope. And then on G, you'll be asked again just to show us that you can calculate the average rate of change from the maximum to the minimum. Thank you for watching this video. Give me a thumbs up if you made it all the way to the end. Kudos to you. See you next time.